Hello. All right. Hello, guys. Welcome to the session. Let's get started. Now, welcome to this specific topic on embedded systems. I presume that you would have already attended the first part of the orientation session of the CLAP program, Telelabs Placement Assured program, right? You would have understood different problem pain points, what's happening in terms of product company hiring, why is it we're not getting a core company job, why is it these companies don't visit our college campuses for recruitment, and let's say, for example, what are the challenges that you guys face in terms of learning outdated skills, why is it not upskilling yourself in the right methodologies, etc. I can keep talking about, right? But the next point that comes is, okay, now that I understood what is the problem statement, what is the solution? Okay, for example, what are the latest technologies that exist in embedded systems? What is that I must know? Okay, what is existing or happening inside the industry? What are the basics to the most advanced which I don't know? So that we'll be discussing that little bit in depth, right? At the same time, the same thing is also a little bit applicable for this course called as embedded system in automotive design, because the only iteration or only extension there is the domain has a little bit more application towards automobile, but generally embedded system has applications in multiple areas, right? For example, you could have applications in healthcare, you could have applications in manufacturing, you could have applications in defense, etc. Whereas automotive is more of specifically in the automotive domain. Okay, let's get started, guys. Now, first of all, what is this embedded system? We know it. We know it here and there. We know the explanation that is there in the book. All these things, you guys are great. Okay, you even got a C grade, or even you got an S grade or an A grade in embedded system, but that's not going to solve the problem. Let's go back to the very basics. Okay, you have a camera. I mean, today I'm not sure you guys would have experienced what a camera is when we were living in a generation, right? I'm currently 30 years old, right? So when you're looking at this video, so when we were living in a generation, we used to have a still camera. Okay, so if you look at the camera, right, there is a specific purpose to that. What is that? Is it must click pictures, right? Same time, they work in real time. This camera is not just going to theoretically work in advertisements. I can use it. I can really take pictures and look at it, right? They work under fixed time constraints. What do you mean by that? Is you can click these many number of pics, right? For example, you can only click picture when the light is on, light is off, etc. At the same time, the camera also has little bit of software. So when you click it, the frame should open and close, and when you close the shutter, when you increase the brightness, the lens should have more focus. So little bit software, minuscule software, and little bit hardware. Okay, maybe the hardware is a little bit more complicated, etc. Depends on the device. So this is what an embedded system is all about. These four things, they have a purpose, they work in real time, they work under certain constraints, because a still camera cannot shoot a video, right? A camera cannot what do I say, send signals. Okay, its purpose is only to take do something in terms of taking a picture. So they work on the fixed time constraints and certain boundary constraints, and there is always a combination of hardware plus software. The complexity varies from device to device. Now, if I have to a little bit break down, now let's go inside the camera. If you look at it, right, there is always an application software, right? And there is always a real-time operating system. Maybe those days cameras are less communicating, etc. But today they're communicating with multiple devices, right? So the operating system always acts as an interface between the hardware and the software. And then ultimately the hardware consists of the lens, the switch, the light, the focus, etc. and all these things. So these are the three pillars. These are the 3 points in the pillars of an embedded system all about. There's a software, there is an interface to the software, is an operating system on which the software runs. At the same time, this is all embedded to a hardware where the function happens, right? The complete system is basically what we call as an embedded system. Okay, now we go a little bit deeper, right? What is there inside the hardware, right? For example, you have buses, memories, audio converters, I/O ports, sensors, actuators, times and oscillators. All different aspects are there. Ultimately, collectively doing one function. It could be clicking a picture. It could be sending some light. It could be sending a phone signal, something of that sort. And there's a processor which has 2 units, which is called as an ALU unit. You know what is an ALU unit, right? And the other one is basically called as a control unit, right? At the same time, the application software, the operating system, they have different applications of the same. Okay, now what is then the embedded hardware, right? For example, there's always a centralized processor. Remember, I told you, right? There is something called as a ports. There is something called as ICs. There's something called as power. There's something called as processors, switches, ports, etc. Different functionalities are there, right? So this is the physical hardware. You guys know what is this called as? It's called as a PCB board, printed circuit board, on which you embed different things, right? This is the hardware. Now, when it comes to software, right? For example, the typical software that is used for embedded system programming, even in the automotive sector, etc., is C, C++, or you have something called as an embedded C, and sometimes even Java has been typically used. Okay, and the next thing is the languages used, right? Again, if you look at it in terms of number of percentage, or let's say the languages, you compare the number of users who are using a particular language, C and C++ majoritarily used, right? Okay, and then yes, currently of late Java has been developed, and yeah, you do have a little bit of C sharp as well, and you have MATLAB, Perl, Python, because different functionalities. Now what is happening is embedded systems are becoming more and more advanced. For example, let's take LabVIEW, right? I've specifically used a lot of LabVIEW software. The reason is very simple. I studied this engineering domain called as instrumentation. So what used to happen is we used to have a lot of these instruments, right? These instruments had certain compatibilities LabVIEW. So the point is very simple. Let's say there is a valve, or let's say there is a pump or something like that, right? It is by default programmed with LabVIEW. So the moment you connect that specs with the LabVIEW, LabVIEW automatically simulates that particular software. So we are very clearly know that software is applicable for certain things. So likewise, right, there are different programmings that are used, right? For example, you have different areas of application and companies of application. Now, when you come to the operating system, right, you have your Linux OS, right? If you look at the companies that operate, or in other words, right, let's take a Toyota. They manufacture cars. Airbus, what do they manufacture? They basically manufacture aeroplanes, right? So in their aeroplanes, there are a lot of very complex electronic systems. For example, an aeroplane has very, very advanced system compared to a car, right? There are other companies like Sandian National Laboratories, Rodin Schwarz, all these things, right? So they have been typically using Linux OS. So different softwares have been used by different companies and different applications. Similarly, there is something called as a VxWorks, one of the very prominent, OS system that's used for embedded system, right? Companies like Boeing, you know what does Boeing do? Again, manufacture airplanes. Collins Aerospace is typically into defense. Bosch, everybody knows about. You know the camera, right? Olympus, etc. Right? And Rockwell Automation is typically around instrumentation. For example, specifically Rockwell Automation is in the domain of biomedical, right? For example, all bio instruments used to measure diagnosis, human health, etc., and all those things. So different systems have different OSs that run behind them. There's nothing right and wrong about certain OS. It depends upon which is more useful, which is more prominent for you, right? Now, when you look in terms of application, okay, where do you actually take this embedded system? Where can you actually apply it in real time, right? There is something called as a swarm robots. It's a very interesting theory. Okay, first let's go through the theory, then we'll have the practical application of the same. Now, what is swarm robots is that they always say that, right? If one ant really comes to you, you can always stamp it because it's just an ant and you're a very big human being. If let's say you have 1 million ants that come to you, right? You yourself kind of have a fear, right? You will immediately go search for a spray or something. You will not just do it with your hand like this if 1 million ants really come, right? Similarly, right, a big fish always eats a small fish. We all know this simple concept, right? A big fish always eats a small fish. A shark can always eat a small fish. But let's say there are thousands and lakhs of fishes that come together. Even the shark or the big fish will have a concern. So this theory has been fundamentally inspired by the nature itself, and this theory fundamentally relies heavily on numbers for a strength. What do you mean by numbers for a strength? Is, for example, there is something called as a robo beast. Okay, not the actual beast, but a robo beast. But as per the actual bee, right, it is in a size of a 1 cent coin or even a 5 rupees or a 1 rupee coin. Okay, so what is a robo bee use is very, very simple. Okay, for example, it's used in a concept called as cross pollination, rescue operations, surveillance. For example, of late you've been hearing some news, right? Little bit news has come. There's a small kid who fell inside a bore well. Somebody was stuck inside a mine in a very remote position, right? Who where human cannot go there and kind of save him, etc. These robobees kind of accurately help us to detect what is a position, what is happening to the person, or something that is existing there. For example, let's kind of imagine, very for example, right? I'll tell you where robobees are used. I read a very interesting article in China, right? There are a lot of caves, very, very deep caves, and inside this caves there are a lot of bats. Okay, the problem with bats is you take this entire coronavirus, etc., Nipah virus. They've been consistently telling that these bats come from animal viruses, especially bats. So it's not so easy to go and access these bats. So in those areas, they use this remote bees to kind of detect what is happening there in terms of signals, in terms of pictures, etc., etc. Very interesting application. For example, let's look at another application of a swarm robot concept. Okay, you take Amazon. You look at this warehouse, right? You can see right on your screen, right? For example, in this warehouse, right, there are different blocks that are there. Okay, different parcels, different units put together. For example, books are all together, or maybe let's say the goods are categorized as per the delivery order, or as per the fulfillment order, or as per the offers, etc., etc. So what happens is no man enters that space. Okay, there's not even one man who's going to enter that particular space, but still all the processing happens. Why? Because they use this concept called as the swarm robots, where they kind of club together based on certain clusterings. Okay, for example, the best example for swarm robots, right? The concept theory behind swarm robots is your honeybees, right? You have seen this honey thing that extracts, right? Around that place, always a lot of honey goes in sticks, right? So, I mean, a lot of honeybees go on stick, right? So, very similar concept, which has an actual application in real time. Okay, the other thing is the military drones. A very, very sensitive application, right? For example, let's say you're in a particular border. India and China have been fighting for a very long time, right? You can't straight away jump into the, your enemy's border and understand what is the scenario, right? And that's where you use these micro drones for deliveries. Okay, of course you can use a bigger drone; it'll get a more accurate picture. But again, it is so easily visible that the enemy might even shoot it. Whereas in U.S. Army, right, especially in the part of defense, right, in the borders of, let's say, Mexico, or when they have their war zones in areas like Afghanistan, Israel, etc., Iran, and all these places, right? They can't easily go into all the places because the enemy is out there in that particular place. So they use these micro drones to understand what is the scene around there, because people naturally think it's like an insect or something that's coming around. They won't even understand, because look at it, right? The soldier is holding that in the hand. It's as small as basically a bee, or even a basically in terms of a size of an insect or something. So very interesting applications of embedded system. So what is it you guys must know about embedded system? Okay, whether it's an application in automotive sector, or it has an application in any other appliances, or defense, or railways, or manufacturing, etc., etc. First of all, you need to understand the very basics of it. Okay, what do you mean by very basics is, what are the different communication technologies that the device has with something else? Okay, any device for that matter, right? You take a drone. A drone is not everything functional by itself. It needs to send some signal, which is basically a video, or let's say a stream of something like that. It needs to send it to the user base. So the different technologies they use, for example, they use something called as Wi-Fi, which everybody knows about. There's something called as Zigbee protocol, which is as good as a Bluetooth, right, for a much larger distance. There's something called as an RFID tag. For example, when you go through toll gates, right, if you've been noticing off late, they give you something called as an RFID tag, fast tag tag. Okay, it's called as a fast tag, but the actual technology is an RFID technology. Okay, there is something called as an infrared. Remember, we used to in those days have an infrared mode of communication. Likewise, there are different technologies on which communication exists. This is the first thing you must involve and understand. The second thing is hardware. Okay, and this is where the problem comes. Whenever I go to engineering college, they ask this question to students. Hey, give me some list of processors that you guys have been using. They kind of tell, sir, we've been using 8051, 8056, etc., etc. I tell them, look, when we were functioning, right, the systems are very, very simple, guys. So it is very much convenient to use an 8051 or 8056. It's not, it's become useless today. The point is, today you have much more advanced hardware systems, much more advanced PCBs. For example, something like Raspberry Pi or an Arduino, which has much more complex functionalities compared to a simple chip of a 8051, or even a simple printed circuit board, right? So hardware technologies are very, very important, along with the basic technologies that we learn. And point number three is the language and the operating system, right? Predominantly what is used is C. Okay, we already discussed that part. And yes, after that, Java has also been regularly used. And Arduino has a software by itself. For example, if you have an Arduino chip that you're working upon, right, you're using that as an embedded system for, let's say, a certain appliance or IoT device or something like that, then you need to understand Arduino language or Arduino programming, because that's where the program runs upon. Okay, and it's pretty universal. A lot of devices do use Arduino programming. There's also, you can code with Python. There's also the old classical Linux, which you can use upon. And of course, the Perl is something also you can use upon. But again, classically, C has been always the very favorite thing. There's a thing called as right and wrong languages or operating system. It depends upon what is that you want to learn and what is that you want to get into. Anyway, just stay curious. We will definitely understand down the line. And most importantly, if you look at the applications, right, for example, let's take the same Arduino board, right? There is something called as a servo control, okay, using an Arduino built timer controller. For example, there's a servo motor or any of the functions, right? So there's an Arduino that is built there, which kind of sends signal to kind of switch it on, control it at a specific speed or something like that. This could be, for example, right, I can give a simple application. You take a laptop, right? You have a fan which is present there, right? The fan needs to work only when the temperature reaches beyond some point of time. And the fan does not need to run in the same frequency, right? When the heat is little bit less, the fan can run relatively in lower speed. When the heat is very, very high, the fan should run in a very, very high speed. So the heat can be controlled. I mean, the fan speed can be controlled based on the heat that has been dissipated by the hardware systems. So many such interesting devices which always exist and projects that actually exist, right? So that comes us to the almost the last 2 minutes of the session. What is this embedded system? What is this placement assured program all about, right? Look, there are different domains that you can pick. I know you guys are interested in embedded system design, or perhaps embedded system design and automotive. Eventually, the one and same. but it's just that the application is more towards the automotive sector, right? The problem is you guys always think there is certain department qualification of addressing particular aspects, but we are very, very clear, guys. It doesn't necessarily matter. You might always come from School of Electronics, you would come from School of Computer Science, you would come from School of Mechanical. All these programs are still eligible for you. Why? Because in one way or the other, these programs are cross-functional by itself. For example, you might be from CS background. You might have a very limited, hardware knowledge. We can still enroll you for an embedded system course or even an embedded system automotive course. You might be from a CS background. You can still work in an automotive company because you will learn a little bit of hardware technologies. Your domain is still fitted because your software is already very, very strong. Let's flip the story. You are coming from electronics background. You have a very, very strong hardware section. Hardware knowledge. But there's little bit software knowledge of, let's say, C, Perl, Bash, Python, etc. And all these things are missing. We can always cater to you there. So the function is always cross-functional type. All this department, engineering department classification, my department is different, your department is different, is a college behavior, guys. But in reality, every department is always very, very cross-functional. So don't constrain your brain that you are from mechanical, this thing is not eligible for me. You are from computer science, this thing is not eligible for me. It is always eligible for each and every one of you, as long as you have the necessary interest and you develop the skills during the course. Okay, and the best part is, we still have been able to work with clients. Even during a pandemic, we will be still able to place students. Okay, for example, right, if you look at it in January, right, before all this pandemic started, 16 students enrolled, we've been able to place 17 students. How? Because one student got multiple offers. So we have been all consistently able to maintain a very, very strong placement record. For example, look at this. In February, 21 people joined, but only 13 people got placed. Okay, whereas the next month, 18 people joined, 31 people got placed. So cumulatively, we've been strongly able to push for placements. That's why, to the extent where we are even able to give a 100% placement guarantee. That is a very, very interesting part of it. And yes, there has been a very strong historical record where students have been able to place themselves in the domain of embedded system, and especially in the domain of automotive, etc., with very good companies that is right there on your screen. Right? For example, you can name companies like Harman, which is a company of Samsung. You could name company like Continental. You could name a company like Cient, which is specifically designed into the automotive sector. You could name a company like Altron, which manufactures equipments for metro, etc., and all these things. So many such companies, Tech Mahindra, especially in the automotive sector, Quest Global, especially in the automotive mechanical sector, Continental, again, the automotive sector. At the same time, electronics also has applications. We have Sony, we have students who are working in such excellent companies. Aerospace, guys, nothing is less for you. You've still been able to get your job in those kind of companies, in Collins Aerospace. So yes, there's always enough data to clearly prove that this works wonderfully well, and you can guide yourself in that. So if you're interested to know further details, right, you want to know what is the cost of the program, probably what is the subsidy that's available at this point of time, etc. What I would suggest you to do is very simple. Okay, quickly take out a phone, note down this particular number, save it in your contact as Kerry Labs. Okay, Kerry Labs Clap or something like that. Type a WhatsApp message, Clap query. Clap stands for Kerry Labs Assured Placement Program. Clap query with your name, phone number, email, and your query. Send it to this number. Immediately, the next few hours, or let's say the next day, me and our team will get back in touch with you for solving any further queries. Okay. So what I'm going to do is that I'm going to exit this session. Okay. So the session will stop after the next few seconds. So what you can do is you can quickly hit the pause button, note down this number for any further queries on all the technologies that we discussed or anything regarding enrollment. We'll be able to get in touch with you. Okay. Thank you so much, guys. I'm signing off. Pause the screen and note down this number, and you guys know what to do. Thank you so much. Bye, guys. Just pause the screen.